So the last type of limits that we're going to address algebraically for rational functions are the ones where I'm asking you to find the limit around an asymptote. Okay, so I need to show you how algebraically that looks. Okay, now we've already done how to find the limit as x approaches 1 graphically, but now let's look at how I would do this algebraically without having to look at the graph. So if I go back to my notes, that is there we go. That is our third scenario. So I'm referring to this scenario right here. And the third scenario that doesn't work with the direct substitution, it doesn't work with factor and cancel. That means that this section will be dealing with limits that are either infinity, negative infinity, or does not exist. And again, that is because we are going to be looking at places where the graph would have an asymptote. So for example, if I were to look at this one and say, what's the limit as x approaches 1 of f of x, the limit's going to be does not exist, because one side, the left side, approaches negative infinity, the right side approaches positive infinity, so the overall limit wouldn't exist. Now, the other scenario that could have happened is if the graphs both approach positive infinity from both sides, or if the graphs both approach negative infinity from both sides. So we're going to have three scenarios. We're either going to get does not exist, positive infinity, or negative infinity for this scenario. So if we look at our notes, whoops, there we go. Looking at our notes, that is scenario 3. And this happens if I try to substitute in, so when I find an f of a, so if I try direct substitution, but I get k over 0, which means a number over 0. Or I still get k over 0 after factoring and cancel. Then the limit doesn't exist. But we can't stop here. We need to specify, does this limit just not exist? Or does it go towards positive infinity or negative infinity? So what we need to do is we need to split, I'm not going to highlight, so I'll do a yellow color. We're going to split your limit, split the problem into two limits, a limit from the left and a limit from the right. We'll find the limit of each one. They'll either be positive infinity or negative infinity, and then we'll evaluate the limit overall. So let's do one of these problems. I'm going to look at example 3a. And again, we still always need to double check with direct substitution first. So we're always going to try direct substitution first. Okay, so I'm going to try direct substitution. I'm going to substitute in 2 for all my x's. So if I substitute in 2 for all the x's, I'm going to have 4 plus 5 over 2 minus 2, which is 0, and that's 9 over 0. So if I get a number over 0, I know that my overall answer, maybe I don't want to write it that way. Maybe I want to say, I know that my overall answer is either going to be positive infinity, negative infinity, or it could be does not exist. And I need to figure out which one it is. So the way that we do that So we need to split this up into two limits. A limit from the left and a limit from the right. So let's work on the limit from, well, I'll just draw it out twice. Okay, so I need to find the limit as x approaches 2 from the left of 2x plus 5 over x minus 2. Then I need to set up another problem. The limit as x approaches 2 from the right of 2x plus 5 over x minus 2. Now, I know that that both of these scenarios are either going to be infinity, negative infinity, or does not exist. And so for the individual left and right-hand limits, I'm only going to get positive infinity or negative infinity, positive infinity or negative infinity, because remember the graph of a rational function, we're talking about where the graph would have an asymptote. And so whenever the graph is approaching a vertical asymptote, that graph is at that vertical asymptote is only going to approach negative infinity or positive infinity. So I know that the left side of the function is only going to be positive infinity or negative infinity. The right, positive, or negative. It would only be does not exist. That would only apply to the overall limit. Okay, so I have to check whether or not the left side approaches positive infinity or negative infinity. And I only really have to worry about the sign. So what I'm going to do is I'm going to think about numbers that are on the left side of 2. And I'm going to think in my head, okay, so a number that's on the left side of 2, but also really, really close to 2 would be like 1.999. So in my head, I'm thinking, okay, if I substitute in 1.999 plus 5 over 1.999 minus 2. Okay. All I have to do is think about the sign. So and I know like my division rules. So 2 times 1.999 is a positive number. Plus 5 is another positive number. So I know that no matter what, the numerator is going to be positive. On the denominator, if you take 1.999 and subtract 2, you get a negative number. Okay? So now what happens when you divide a positive number by a negative number? You get a negative number. So that means the limit as x approaches 2 from the left is negative infinity. Now I'm going to do the same thing for x approaching 2 from the right. I just need to check, am I going to approach positive infinity or negative infinity? So a number that's on the right side of 2, but also really, really close to 2 is 2.001. So in my head, I'm thinking, okay, I'm going to substitute in 2.001 for those x's. So 2 times 2.001 plus 5 over 2.001 minus 2. And I'm only thinking about sign, so I don't even need my calculator here. 2 times 2.001 plus 5 is a positive number. 2.001 minus 2 is a positive number as well. And a positive divided by a positive is positive. So the limit as x approaches 2 from the right is positive infinity. So if the limit, let me grab my yellow here, if the limit as x approaches 2 from the left is negative infinity, and the limit as x approaches 2 from the right is positive infinity, positive infinity and negative infinity are not the same. So then the limit as x approaches 2 of the overall function does not exist. So we have answered our question. We know we can say that the limit as x approaches 2 of that function does not exist. So then let's look at example 3b. I'm going to have to erase because I took up a lot of space there. Whoops, 3b. Erase, 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 erase. Okay, so this time, I'm going to draw a line there. This time, I'm finding the limit as x approaches 0 of 4 over x squared. Now, if I substitute in 0, remember to try direct substitution, I'll have 4 over 0 squared. So that tells me, which is a number over 0, so that tells me my overall limit is either going to be positive infinity, negative infinity, or does not exist. Okay, so then to determine what the overall limit is, I'm going to split my original limit into two limits. I'm going to split it into the limit as x approaches 0 from the left of 4 over x squared, and then the limit as x approaches 0 from the right of 4 over x squared. And remember, we're only checking signs. So then to evaluate the limit as x approaches 0 from the left, I'm going to think of a number that's on the left side of 0, but really, really close to 0. So like negative 0.001. Okay, so I'm going to substitute that into my function. So 4 over negative 0.001, close parentheses and squared, because I'm putting that negative in for the x. And let's see, 4 is a positive number, and negative squared is also a positive number. And also, when I'm breaking this up into limits from the left and the right, I know that these answers are only going to be either positive infinity or negative infinity. Same for the limit from the right. So it'll be positive infinity or negative infinity. Okay, so back to the limit as x approaches 0 from the left. Well, if I get a positive divided by a positive, that is going to equal a positive number. So the limit as x approaches 0 from the left is positive infinity. Now, the limit as x approaches 0 from the right, let's think of a number that's really close to 0, but on the right side of 0. So a number like 0.001. Substitute that in. So 4 over 0.001, you can put it in parentheses, squared. And 4 is positive. 0.001 squared is positive, and a positive divided by a positive is also positive. So that means the limit as x approaches 0 from the right is positive infinity. Now it's time to answer the question, what is the overall limit as x approaches 0 of 4 over x squared? It's only going to be one of these three. Well, the limit from the left is positive infinity. The limit from the right is positive infinity. So that means the overall limit, since these are both the same, is positive infinity. Okay? Now, when you go to do your assignment, do I have it pulled up already? When you go to do your assignment, you're going to notice that there's not specific sections for each type of problem. And my internet is kind of lagging right now. There's not specific questions for each type of problem. So what you're going to need to be able to do, sample student page, what you're going to need to be able to do is determine when you need to use what method. So let's see. That's the quiz. Okay, see, right here, notice that there is only one section. And so all the problems are going to be mixed together. So you're going to have to figure out what method do I use. So I'm going to direct you back to the notes there and show you that method that we went over at the beginning. That's the method that I want you to follow. Erase. So sorry for all this moving around here. So the first thing that I want you to do is I want you to try direct substitution. Always try direct substitution first. If direct substitution doesn't work, or if you get 0 over 0, then you can try factoring or canceling. If you get a number over 0, so that constant over 0, then that's the scenario where you need to split it into two limits. Okay, so you've got three different scenarios here. That fourth scenario called indeterminate form, that's something we're going to address later on this year, so don't worry about those just yet. Just worry about these first three methods, okay? So good luck with this lesson. If you need questions or you have anything, just let me know. All right.